Problem 12.28 states that block A has a mass of 10 kilograms, right there. And block B and C have masses each of 5 kilograms, so that's a given right there. Note the blocks are initially at rest, so that means that the initial velocity of each one of the blocks equals 0, and that B moves through 3 meters in 2 seconds. So at a time at 2 seconds, the change in position of B is 3 meters. It wants us to find the force P and the tension in the cord AD. So that's the tension in this line right here. And neglect the masses of the pulleys and the actual friction. So all X's will be measured downward from right this level right here. And so looking at our string theory, for this first string, we would have X sub A plus X sub D to within a constant. And then take the first derivative, you get this equation right here. Take the second derivative with respect to time, you get that equation right there. Then we'll look at this string over here, and it's going to be measured as X sub B minus X sub D. That's the position of B with respect to D right there. And then the position of C with respect to D right there. So it's XB minus XD plus XC minus XD equal to a constant. Go through and take your time derivatives. You're going to have 2 of these XDs right there. So we'll get a VB plus VC minus 2VD equal to 0. Take another time derivative, you get the acceleration of B plus acceleration of C minus 2 times acceleration D equal to 0. All right. Now, if we do free body diagrams on each one, and I'll try to scroll this so that you can see the figure and the free body diagrams. Look at object A right here. There's a force of gravity. Yes, that's MAG. And there's a tension T1 up in the line. Look at the free body diagram on B right there. Is there a force of gravity acting on it? There's the MBG there to represent that. There's P to represent that. And there's a T2 in this other line. Free body diagram on C. We'll have just a T2 up minus MCG downward. And actually, it's not going to be minus because the positive direction is downward for us. So the free body diagram on D is going to look like this, and so forth. Now, we're going to look at the Newton's second law for each one of these things. And the way I wrote it out was as if positive was upward, but that doesn't make any difference in the calculations, because over here, the things that would have changed if we had taken positive as upward, there would be a minus sign in front of each one of these, and you can see they would cancel out through here anyway. So, and turn the equation back into the equations that they are stated there. So, second law for A, sum of force from Y equal to M times A sub Y. So we got T1 minus MA G equal to MA times A sub A. For B, and I forgot to put the B right there, but it's a summation of forces in the Y equal to M times A sub Y. You got T2 minus P minus MBG equal to MBAB. For C, you got this equation right here. And for D, you got that equation right there. Notice that delta X sub B would be equal to the initial velocity of B, which is 0, plus 1/2 A sub B times time squared. And since you're given the information on position and time, you can calculate that A sub B is 1.5 meters per second, which is downward, but it will be negative in our equation. So what I'm doing next is setting up to do the simultaneous equation solutions, where we're looking at our unknowns as being T1, T2, P, A sub A, A sub C, A sub D. So there's 1, 2, 3, 4, 5, 6 unknowns, and we should have 6 equations. So this first equation right here is coming from this term right here, where we got a 1 times T1, we got a 0 times T2, we got a 0 times P because it doesn't appear in those equations. Now, we got a minus M sub A, A sub A, because you put this over to the other side. And then you'd have a 0 times A sub C and a 0 times A sub D because they don't appear in that equation. And then what they'll be equal to is MAG, so they put it to the right-hand side there, and you get to this right here. Same thing for this one here. You can see there's no T1, there is a T2. There's a minus P. There's a minus MBAB from, but that's AB is known, so it'll stay over here. Put the MBG over there with it, so you have that term right there, and the rest of these unknowns have coefficients of zeros. And you keep doing that for this equation and this equation right here, and then you do it again, and that's this equation. This equation right here is corresponding to that one right there. And then we write out an equation for those two acceleration equations that we had here and here, and then we'll solve simultaneously, and we do pick out the answers that they want us to pick out, and that was what is the tension T1, which is 103.1 newtons, and the pull is 10 newtons. Now, this is one way to do the problem. Obviously, we got 6 equations, we have 6 unknowns, but there's enough information that you can go back in, for example, and put that value of AB in here. Then you get you can solve for AD in terms of AC. You can put these equations together and simplify them down, stick them back into these equations right here. It's a little more complicated, but the answers will come out to be the same.